So today in class, we finished up our gas laws. We did Boyle's law on Tuesday, which was yesterday, and today we did Charles' law and Gay-Lussac's law, and then we did the combined gas law. Now, with these gas laws, I'm only able to calculate three different variables. I'm able to calculate pressure, I'm able to calculate volume, and I'm able to calculate temperature. Notice temperature is always in Kelvin. Now there is a third gas law, and that's what we are going to do today. And that gas law is known as the ideal gas law. And what is useful about this gas law is that it allows us to calculate a fourth variable which is the number of moles. Now, if we look at the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2, notice that we can only calculate pressure, volume, and temperature, not the number of moles. So the formula for the ideal gas law is it is PV equals N, lowercase n, RT. I'm going to put a box around that guy because I like to put boxes around our formulas. Now let's go ahead and label what each of these means. So P obviously stands for pressure, and pressure needs to be in ATM in atmospheres. We've got V, and V stands for volume, and volume needs to be in liters. We've got N, and N, that is the number of moles, and that's just abbreviated MOL. We've got T, which stands for temperature, and temperature needs to be in Kelvin. And last but not least, we've got this R, which is the gas constant. And the gas constant is always the same number. It's 0.0821, and the units are liters times ATM all over mole times Kelvin. So what's helpful, or what's different about these two formulas, is notice the main difference is we're able to calculate the number of moles using PivNert, as I lovingly call this guy, PivNert. Whereas in the combined gas law, there's not a calculation for the number of moles. So let's go ahead and let's do a couple of sample problems using PivNert. So for example 1, I'm just going to give you a set of circumstances. So P, V, N, and T. So let's say pressure is 2.5 ATM. Let's say volume is 32 liters. And let's say N is equal to 3.1 moles. And they want us to find temperature. So I've got my formula, which is PV equals NRT, PivNert. And first thing I'm going to do is double check that these units here match up with these units on this gas constant. So ATM, ATM, liters, liters, moles, moles. So we're good to go. So now I'm just going to plug and chug. So I've got my P, that's 2.5. My volume is 32. N, which is the number of moles, is 3.1. R is always 0.0821. Always, always, always. So R is always 0.0821. And they want me to find temperature. So I just leave that as T. So in order to solve for T, I'm going to circle T because that's what I'm trying to solve for. So notice these are all being multiplied right now, but I want to make sure that they get do the opposite of that, which is division, in order to solve for T. So I'm going to divide each side by 3.1 and 0.0821. So make sure you divide on each side. So these guys cancel out nicely. And when you type this into your calculator, you're going to get T equals 314.329. Now there are, just look back at your problem, 2, 2, 2. There are two sig figs. So your final answer is T equals 310 Kelvin. So notice where I came up with the temperature unit of Kelvin, I use this constant up here. When I plug in 0.0821, it has to be liters and ATM and moles and Kelvin. That's what that constant is. So the K, that belongs to temperature, so T is going to be in Kelvin. So let's do one more of these problems. So example 2, let's say that the pressure is 3.17 ATM, and let's say the volume is 396 milliliters, and let's say N equals 3.1 moles, and they want to find temperature again. So the very first thing I'm going to do is check my units. Okay, now these units, they need to match my gas constant units. So it needs to be liters for volume, atmospheres for pressure, moles, not grams, and it needs to be in Kelvin for temperature. Now, I'm noticing that my volume is in milliliters. According to the gas constant, I have to be in liters. So the first thing I'm going to do is I'm going to convert milliliters to liters. So milliliters goes on bottom, liters goes on top. Liters is higher up. The mighty King Henry ladder gets a 1. And milli, that's going to get a 10 to the 3. So milliliters cancels out. And I'm left with 0.396 liters. So now my units match up. ATM, ATM, liters, liters, moles, moles. So I'm able to plug everything into Pivnert now. So I've got my formula. PV equals nRT, where pressure is 3.17, volume is 0.396, N is 3.1, and R is always this number, 0.0821. And temperature, that's what we want to find. So I'm just going to leave T there. So I want to solve for temperature. So I divide each side by 3.1 and 0.0821. So those cancel out. 3.1, 0.0821. So I type this all into my calculator, and my calculator spits out T equals 4.9323. And there are 2 sig figs is my lowest number of sig figs. So my answer can only have 2 sig figs. So my final answer is T equals 4.9. Now T is temperature, and according to my gas constant, my temperature has to be in Kelvin. So I'm going to go ahead and put a K for the unit for temperature and box that guy up, because that is the correct answer. Now, if you get out your, not your homework, but if you get out 13.3, so it looks like this. If you don't have it, just pause the video and find it. So what I would do for this is go through. If I have 4 moles of a gas, actually, these are all the ideal gas law, which is Pivnert, PV equals nRT. And I'm going to write P, V, N, and T. So if I have 4 moles of a gas, that's N. That's the number of moles. So 4 moles at a pressure of 5.6 atm and a volume of 12 liters. So volume is 12 liters. What is the temperature? So they want us to find T. So I write my formula. PV equals nRT, and I plug and chug. P is 5.6, V is 12, N is 4, R is always 0.0821. Let's go ahead and let's write that up here. So R equals 0.0821, and the units are liters times atm all over moles times Kelvin. So what I should have done first is double check my units. Atmospheres, atmospheres, liters, liters, moles, moles. So I was able to plug everything in right away. And then they wanted temperature, so that's T. Remember, they don't give me R in the problem. They didn't give me R because I always know R is that number. So I always plug that number, the 0.0821, in for R. So I want to solve for temperature. So I'm going to circle this guy. So I divide each side by 4 and 0.0821. So I cancel out those guys, and I'm going to type that into my trusty calculator. So, on, clear. So 5.6 times 12, hit divided by 4, and hit divided by again, 0.0821. So your calculator spits out this answer. It spits out 204.62. Now, because of the 4 right here, there's only 1 sig fig. So temperature is going to equal 200, and the units of temperature, they're in Kelvin. Okay, so the final practice that I'm going to ask you guys to do is, before you come to class tomorrow, try number 2, and then try number 3. So go ahead and do 2 and 3 on 13.3, and email me if you're confused about anything, and hopefully I'll be able to get back to you. Okay, have a great evening.